Hello, everyone. My name is Keith Jackson, and welcome to Jack's Math Notebook. Right now, you're looking at the parent functions that you are likely to see in algebra, and here they are. The first one we're going to talk about will be the absolute value function. Then we're going to move on to the identity function, then the exponential function, followed by the quadratic function, and then lastly, the square root function. First, let's go ahead and talk about the absolute value function, in which function of x is equal to the absolute value of x. Now let's not get worried about the lingo here. It's really saying y is equal to the absolute value of x. We can look at it that way, but from now on in algebra, you're going to see this terminology right here, like the function of x is equal to the absolute value of x. And the absolute value of a given number is always positive. And let's take a look at it right here. Let's put 1 inside our function. And let's say the function of 1, okay, is going to equal to the absolute value of 1, which is 1, right? And your function of x is really your y value. And so right here, if we follow this line right here, you'll notice that we'll have a 1 right there as we go up, okay? And likewise, let's put in a negative 1. And we'll say the function of negative 1 is equal to the absolute value of negative 1. But remember, absolute values are always positive. And so if we go over here on the x side, right, as long as on the horizontal axis, which is x, and let's say we land on negative 1 here, and we want to get its absolute value of negative 1, well, it's going to be positive 1 right here. And so then this is why this absolute value function is V-shaped. That is precisely why it is. Now, here's the behavior of an absolute value function, or right here, this particular absolute value parent function, in that x values are going to be all real numbers, meaning that as you go to the right, it's going to continue to the right forever, which is positive. And as you go to the left, it's going to continue to the left forever. Okay, so that's the domain. So the domain will be all real numbers. The range, however, well, guess what? It begins at 0, and then it continues to go up forever in a positive direction. And this is why we're chasing infinity, because it's positive infinity. Your range will be 0, comma, positive infinity. Now let's go on to the identity function, in which we have the function of x is equal to x. And if you notice right here, let's say we put in a function of 1. Well, the function of 1 will equal 1. That's right, because that y value right here will be 1. And let's do the same thing for the function value, or I should say function of negative 1. And of course, when we go down here, we find that it's negative 1 as well. Okay, so that's what we see right here for the identity function, and that's how it works. And the domain will be all real numbers, because as you go to the right on the x line on the horizontal axis, it will go on forever. And the same is true if you go to the left on the x or horizontal axis, it will go on forever. And that's why the domain will be all real numbers, because the domain deals with all the x values. Now let's talk about the range values, because the range is talking about up or down. And it too will be all real numbers, because as this graph continues to go on into infinity, it will go up to infinity, as well as it will go down to infinity. And that's why the range right here will be all real numbers. Now let's take a look at the exponential function, in which we have, let's say, the function of x is equal to b raised to the x. And so this parent function will be function of x is equal to 2 raised to the x. And right here, as you can see, the domain will be all real numbers. And the range, well, it has a limit right here at 0. It will never touch 0. It almost behaves like a horizontal asymptote. And so with that in mind, the range would be from 0 all the way up to positive infinity as you go up. But its limit is at 0. That's why the range here will be 0, comma, positive infinity, because it can only go up from here. All right, and let's go to the quadratic function, in which we have function of x is equal to x squared. And your quadratic function is going to look like this. And your domain value will be all real numbers. But on the other hand, your R values will start at 0, and then it will go up to positive infinity right here. And this is what this designates right here. I made a slight mistake by writing all real numbers, and then I caught it, and I said, well, that couldn't be possible, because it's 0 right here in this case, and it's not going to go below 0. And so 0 is where it starts. And this is why we put this square bracket right here, indicate that it's that 0 cannot go any further down than 0, but it can go all the way up to positive infinity right here for this quadratic function. And then we have the square root function, All right, and the domain right here has its limit right at 0, but it goes to positive infinity along the domain along the x-axis, the horizontal axis. And the same is true for the range, in which it also starts at 0, but it goes up to positive infinity as well. And this would be our square root function that you will likely encounter in algebra as well. All right, now here are the types of transformations that you will see when you're dealing with these parent functions. All right. Remember that a positive h will make the function go left. I know it sounds counterintuitive, but in future videos, I will explain that to you. Also, negative h will cause a function to move right. And so when we think about h, it's either going to move left or right. And then we have a positive k, and the k, that's the one that's true. If it says positive k is going to move up, the function will move up. If it says negative k, it would move down. All right, so we'll move down k units right here. If it's positive, it will move up positive k units, right? And again, right here, if it's a negative h, right, negative h value, well, it's going to move right h units. And right here, if we see a positive h, it's going to move left h units. All right, you have received a lot of information, and I wouldn't blame you if you need to pause the video to just kind of take a look at things or replay this video as many times you need to gain a deeper understanding of the parent functions that you're likely to see in algebra. With that in mind, please comment, share, like, and subscribe to Jack's Math Notebook for more content. Thank you and goodbye.